Greetings. I welcome you all to the next lecture of this course, wherein we were now discussing on electronic waste recycling. And previously, we had just a discussion on how important it is to sort the waste streams and basically arrange the waste stream in the broad categories and perform the operations, manual dismantling and let us say shredding and separation of materials. Now, we have already studied the basics of various materials processing and the important strategies that are involved in extracting valuable materials. Now, this strategy we will be developing for different types of wastes, of e-wastes, the different categories of e-wastes. We will now continue where we had left previously. So, we have seen that physical operations is very much important. Manual dismantling is very important. We are able to separate out different components which otherwise would directly be ending up in the shredder. So, suppose if we have, let us say, an AC, discarded AC or a discarded washing machine, we just put it in a shredder. Now, irrespective of whether it is an automatic front loading or top loading machine, we just put it in a shredder. What will happen? The components will break. The PCBs will be dismantled. Everything will be shredded in a suitable shredder. And then what we get is a combination of materials. Now, whatever materials were present in the manufacturing will mostly be present unless until, of course, as we had discussed previously, that we have reasons due to which particular material or parts of it are removed. It could be due to, let us say, mechanical wear or due to some damage. Now, not considering those cases, we must easily be able to get out almost all of the materials that we feed in. And those materials that we feed in is actually those materials that were used to make the electronic device. Now, we must note that the operations that we choose in a recycling unit are very important, and we have studied it just till the shredding point. What happens beyond that is again one can think of attaching pyrometallurgy or hydrometallurgy or any other type of recycling strategy for the metal recovery or for any other material recovery. Now, we will continue. In most of the electronic devices, and we are talking about electronic devices and not very simple electrical devices. So, we are talking about electronic devices. We will have some sort of, even if it is a rudimentary, we will have some sort of control mechanism, because it is an electronic device, it has to do something. So, it has some sort of control mechanism. It could be very simple on off or any other signal mechanism. Now, that control mechanism is usually governed by a circuit board, which means if we have a control mechanism, we are actually talking about printed circuit board, or we can have printed wired board, PCBs, PWBs. If we have printed circuit boards, we get PCBs, and of course we know that we are going to get WPCBs after it reaches its waste, or WPWBs. Generally speaking, we get a PCB, and we can just club these two terms together. So finally, if we have the circuit boards, we have the uh, mechanism of controlling the various operations that electronic devices perform. And these PCBs are generally made of wide range of materials, which makes it difficult to recycle. And we'll just study a bit more about PCBs. So circuit boards have very large variety of categories, but we can just have rigid circuit boards. Some are flexible, whereas some are rigid and flexible. So we have rigid, flexible boards. So depending on what is the application, we can have a rigid board on which all of the electronic components, ECs and ICs, which are whatever are the components we are attaching them, or we can have a flexible board. Again, that is used only when the application is such that we need a flexible board, or there can be some parts that are rigid and some parts that are flexible. So depending on type of application, we can have rigid boards, flexible boards, or combination rigid flexible boards. And of course, similarly, we have the components that are attached on the PCB. Why are we so much interested in boards and electronic components? This is important because these boards and the components are going to end up almost in pristine state when we are discarding the, let's say, previously we've seen washing machine or ACs. Apart from the wear and tear that happens during the service, most of the materials are mostly not damaged much, unless until it really faces some sort of mechanical damage. Now, what happens to these materials? If we are not so careful, we just put it in a shredder, and then we are shredding the glass fibers, we are shredding polymer epoxies, we are shredding metals, we are shredding all of the electronic components directly that are attached on the PCB, along with the whole of the other waste. Let's say we are talking about washing machine, the whole of the washing machine is getting shredded and PCB is also going in. But if we are able to remove these components beforehand and we are recycling them, then comes the challenge of isolating the important materials that can be directly reused, or ECs that can be removed from a discarded PCB and installed on a fresh PCB. If of course, to that again one has to analyze whether that EC component itself is functional or not, and if it passes, then how are they going to reuse it? That is another way of recycling, and one has to think how are they going to do it. Now we'll now focus on what are the ECs that are normally installed on the boards. Components, electronic. So electronic components can be generally classified as surface mounts or through hole components. So we can have surface mounts or through hole components. What do we mean by that? Now it again is connected to the circuit board. So if circuit boards have through holes in them, if the holes and the interconnects are present in the board, then it is possible to install an EC that has those long small miniature pins that can penetrate through those holes. Now again it depends whether these components are used in the PCB manufacturing or not. If not, then we have surface mounts wherein the components are attached directly on the PCB and these components do not go throughout the PCB, and then the appropriate soldering strategy is done. Soldering can be done behind the board or on top of the board depending on what type of component was used, and then this defines how complex it is to manufacture a PCB. Of course, we are more interested in dismantling a PCB, but it is also important that we are able to understand what are the materials that are used. So the masking, solder masks, the layers that are present in the PCBs, we'll be of course discussing this in greater detail in the upcoming classes, but we know that these layers and these interconnects and the ECs that are installed on the computer or on the PCB, these need to be separated out so that we are able to look at our materials that we are interested in extracting. Now, what do we know about chemical composition of PCBs? And right now I did not write PCBs, now I am talking about WPCBs, because right now I am assuming that we are looking at a waste printed circuit board and it has reached the recycling unit and then we are analyzing. So the most important aspect that one has to think of is what is the source of the WPCB. So if we are not able to isolate the source of the WPCB, it becomes a bit of a question that how we'll be able to recycle it, because PCBs can originate from so many different sources, and we have already seen that the recycling of PCBs or any other waste, e-waste, electronic waste, comes with the challenge of manufacturer. Every manufacturer has its own way of using materials, and those materials can be having wide range of variety. If we look at the whole lot of e-waste that we look, say for instance, we had discussed this, TVs can be produced by n number of manufacturers, computers, laptops, TV screens, tablets, every device has this problem. Variety of materials, in those materials variety of composition. So even if we say, let's say a generalized statement could be we have, let's say 30% of metal. What do we mean by 30% of metal? Do we mean by ferrous metal or non-ferrous metal or platinum group metals? What are we talking about? So that internal division for a waste fluctuates per sample. That is why we need a very good generalized data, and such a data is a very big important input for the recycling industry. We'll continue on chemical composition of WPCBs. So just now we have seen sources of WPCB. This is very important. Again, we are just assuming that we have sorted e-waste stream, and then we were able to isolate the WPCBs. What are the sources? We have discarded PCs and laptops. We have mobile phones. We have telecommunication devices. Washing machines. So we have washing machines. We have ACs. We have so many different other components that will have WPCB. If we have some sort of control in the given device, then there's a fair possibility that there is some motherboard, some printed circuit board that is governing what is functioning, what is the functionality of the equipment. Now, this changes the whole scenario of the composition. Let us see what we are looking at when we are seeing the category of WPCB. So we have waste electronic components. And why are we talking about waste electronic components? Because it's a part of the PCB. So we have, let's say, this is a very rudimentary schematic of printed circuit board. So we have this board. Of course, this board itself is comprising of multiple layers of different materials, but we have various types of components that are attached to it. And so on and so forth. So if we are looking at a waste printed circuit board, we are also looking at the electronic components, and these electronic components have their own properties. So we'll look at these. So the classification is capacitors, integrated circuit, we have ICs, we have transistors, resistors, we have connectors, and at times we can also have interconnects also. So connectors, wires again for connections, we have inductor, diodes, and we see that these components are already present on a WPCB. Now the question comes, can we really directly reuse these components if we are able to successfully dismantle? Now, when we think of direct reuse of these electronic components, one has to think whether they are functional or not. So, and even before we reach to that point, the most important part is, can we really separate out these electronic components without damaging the ECs? This is a challenge. Safe dismantling of electronic components in such a way that neither we are damaging the board nor we are damaging the ECs. And one must mind it that when we are looking at a PCB, this PCB with the electronic components attached to it is generally strong. It won't really break if we are trying to swing it. The components will not fall off. It means that it has been made in a way that it stays safe. So one has to think of a way of dismantling these components and reusing them. Of course, if we can reuse it by some refurbishment, it would be a nice idea. Now, what exactly is the composition of PCB? We know that these parts are there and these parts are called the electronic components. What else is present in a PCB? So, material composition of WPCB. So, we have WPCBs and we have oxides, we have polymers, and we have metals and alloys. And generally speaking, we can have a higher share of metals and alloys, but it really fluctuates a lot. The major components that are present are basically oxides, the polymers, and the metal. And what do we mean by having the division? It means that these materials were used in manufacturing the ECs or the PCBs. So, metal oxides, polymers and metals were used, and of course, some sort of composites can also be present, but these materials were generally used to make the whole PCB and the ECs. What are the oxides that are present? And ceramics. So, if we look at ceramics, in the WPCBs, which are basically oxides. So, if we have SiO2, Al2O3, TiO2, I need to go. So, we have a major contribution of silica, 6.16. This means that the oxides, which are basically generalized in the head of ceramics, so these oxides have a major contribution in the overall PCB construction. And then now we are going to look at what are the key metallic contribution in the metals and alloys segment. So, we will see that if you look at types of PCB, and this is very important, when we look at this table, we see that we have the type of PCB right at the front. This is important that because we see that some data are for PC, so PC, we have for TV, and we have copper and mixed WPCBs. So, this data tends to fluctuate a lot if we are looking at a specific category of PCB, which is why we were discussing so much about why we need to isolate PCBs as well and sort them. We see that copper is one of the most important elements, followed by, let's say, lead or nickel or tin or zinc, but it depends on what type of PCB we are looking. And right now we are looking at the PCB itself, the board, and not the ECs. ECs can have large variation in chemical composition because they have very specific applications. So, specific applications would require specific elements. we are right now looking at the PCB after the removal of the components. We are not generalizing the statement that we have PCB with the ECs, because that really expands the number of elements that we should be putting on this table. Generally speaking, we have really large number of elements in our cell phones right now. So this makes the recycling process even more complex, which is why we are saying that this table is for, and again it's a very short range of data that we have presented. The data can have very large number of outliers also. PCB is discussed, and we see that copper is one of the most important elements. Along with, we have these elements like lead, nickel, tin, lead, nickel, zinc, iron, and of course we also have gold and silver and platinum group metals. Of course, this is presented separately because the units are different. The units are in the parts per million. So gold and silver are also present depending on what type of PCB we are looking at. So phone can have phone PCB, mobile phone PCBs can have silver, PC PCBs can have gold and silver. So depending on what type of waste we are looking at, we will be having wide range of chemical composition variation, and this makes the recycling lot more challenging. Now, which brings us to the challenges. Challenges in e-waste recycling. We have been discussing this a lot, and now we need to just consolidate the ideas. Given the complex nature of the raw materials, in the WPCBs, the recycling becomes a challenge. Some important challenges are, we'll write presence of epoxy resins, flame retardants, phenolic resins, etc. What does this mean? So these materials are added to basically keep the material safe. So flame retardant is added. Why? Because we don't want the PCB to catch fire during its operation. Similarly, we have epoxy resins to basically at times hold the material together. So these resins can be helping in the component attachment. So these materials have their own particular set of applications, which are way beyond what we really intended. But these help in making the component more safe for application. What happens is, after application, we need to remove these components, and if these components are not properly treated, these materials are not properly treated, these can generate hazardous wastes. So presence of resins, and then there is the improper method. Improper recycling methods. This is a very big challenge. Why? Because incorrect dismantling will lead to what? Correct dismantling of the raw materials. In this case, it's a PCB. Of course, we can have different examples also. Will lead to discards of reusable. And what do we mean by reusable? These are potentially reusable components which we could have used, but because incorrect dismantling is done, so we have to basically see that these are actually discarded. And then what happens? Since we have discarded these wastes, we have also unsorted and incorrect, improper metal recovery methods. Unsorted and improper metal recovery methods, these are followed. So what this will do? This is going to lead to lower metal recovery. And this is followed by release of hazardous gases. Which means again, this is environmental impact, harm to surrounding. This is an interconnected problem. So if I don't know how to recycle, I'll just put it in a small makeshift furnace. I'll just shred the PCB and I'll take those shredded scrap of PCB and I'll put it in a furnace. And this furnace may not be safe for processing. It may just release gases, and those gases can harm the surroundings. So improper recycling is a bit of a challenge. It creates potential hazardous materials because we don't know what we are trying to recycle. And this material distribution of PCBs is very complex. So safe dismantling thus becomes very important. So a general statement could be generalized, and we'll be discussing this further in the upcoming classes. General method of WPCB recycling will involve, and we are not even going into recycling, we are just starting to see what are the initial steps and which are basically crucial: collection and sorting of WPCB from various sources. And then we have sorted WPCBs and recovery of materials, valuables. We have separation of ECs, and then we have shredding or mechanical operations, and then we can have milling of WPCBs, and this is a very generalized outline of what we can do. And we know that of course we have dismantling here. We know that this is the most initial and the most crucial step at the beginning, because if we miss this and we just start recycling, and recycling strategies are enormously complex, and lot many research groups have been exploring their own method of recycling WPCBs. So if we bypass this process, we may not be able to control it properly, which is why collection, sorting, and the removal of those components are basically the most important initial steps. When we remove the ECs, now we have cleaned the WPCBs, and now we can recycle it properly. We'll be discussing the recycling strategies of WPCB in the upcoming classes. Thank you.